Good morning, everybody. My name is Sebastian Magri. I wanted to go over something called polarization. And so what is polarization? It really is just this concept, that light wiggles in a certain direction. It might wiggle side to side. It oscillates. That's what it's called. It's called oscillating. It wiggles or oscillates in a certain direction. As we can see through this kind of demonstration, this is just a light wave traveling in, if you're looking at it, to the right. And it's just oscillating up and down. Nothing too special. Yet at the same time, what if we control the way in which light wiggles? For example, let's say we have a lot of different light that comes into it, and it wiggles in all different directions. But we use what's called a polarizer, which is just a fancy word of saying something that lets light wiggle a very specific way. In this case, if we have a lot of different polarizations come in, we might get a single polarization that comes out, just wiggles in one direction. What can we do with that? Well, if we know that a material only allows wiggles in a certain direction, we're able to actually determine stuff about that material. A good example would be a specific cancer cell, perhaps, or a specific, as you'll see in a moment, a material property that talks about stress or that determines stress has a different way it allows light to wiggle. We'll be able to see stuff. We're going to learn about what a linear polarizer is. And what a linear polarizer is, if light wiggles in a certain direction, and we allow, for example, if we have a rope that goes through a fence, if it wiggles through the vertical part of the fence, well, it's just going to go by undisturbed. But what if we turn the fence 90 degrees? One of these fences 90 degrees. Guess what's going to happen? Our fence will block, our 90 degrees fence will block, it won't allow the wiggle to keep going. In fact, it'll block it, which is how a specific two polarizer system, as you'll see, completely block all light coming through. And finally, if we have a polarizer that's angled, well, we'll get a little bit of the wiggle out of it in the specific direction in which it's tilted. So as we come over here, we see, okay, we have a light source in which what appears to be clear, sheeting over the front. However, as we turn this sheeting, you'll see that we're actually able to block out all of the light. Now, there's no battery in here. There's no machinery or anything like that. We're simply just turning this. And that's analogous to literally turning our fence post. Our fence post is actually this guy. We are turning it, and now we're turning it back to vertical where we allow everything through. Now, why is this important? Well, like I mentioned, different materials have different polarization tendencies. Or to say it, maybe a little bit nicer, different materials will curve light in a different way or allow light to wiggle in a different way. So we're going to come back here, and for example, looking at this spoon, we are able to see different stress tendencies. As you can see in the concave part of the spoon, we have a lot of different birefringence or different ways in which light comes out of it oscillating or wiggling. To say it has a different polarization tendency. This is used in manufacturing where we can see the stress inside of the spoon. So if you were to cast this spoon right here into a mold, we can determine, okay, there's probably a high probability that it will fracture at the actual concave part rather than at the smooth part with very little birefringence. Another way in which we can see different polarization tendency is something like this. It's just a jar of corn syrup. Nothing out of the ordinary. But when we turn this, we can see a change in color. And that's because this has a very specific polarization tendency. Now, this is what's called circular polarization. We won't get into that. But the main thing is again, these have very specific ways in which they let light through. And the specific ways in which we let light through allows us to determine what the material is. And that's important because, again, that allows for classification of things like cancer, for classification of faulty materials that might be not, for example, in a manufacturing process, not desired. It allows us to really classify a lot of materials that, or objects that we wouldn't otherwise be able to classify. In summary, the field of optics is at work everywhere, and this polarization is just one example of how we are able to really learn and know about our world on a scale we've never been able to in the past. That said, thank you guys so much for listening.